So we are now going to talk about solving quadratic equations by using the quadratic formula. So previously we talked about solving by the square root property, and we talked about solving by completing the square in conjunction with the square root property. A long time ago we talked about solving by factoring. Now we're adding another method that's called the quadratic formula. So basically, eventually what will happen is you're going to be given a quadratic equation and just told to solve. And you're not going to be told which method to use. And what you need to understand is that you can use completing the square, and you can use this method, the quadratic formula, on any quadratic equation. So my method of attack is always, will it factor? Because I will factor it if it can factor easily. If it can't factor easily, something that I can see really fast, then I go to this method, the quadratic formula. So if I have a choice, I never complete the square. And that's just how I work. This is one of those that if you know the formula, it's pretty easy to plug in the numbers and get the right answer. You do have to be careful with the signs. So if you're careless with your signs, this one's not going to be your friend. You may want to, your go-to may be completing the square. Okay? So the quadratic formula is what we use when we are solving a quadratic equation that's in the form ax squared plus bx plus c equals 0. Notice that the a is the coefficient on the x squared term, the b is the coefficient on the x term, and the c is the constant term. Notice that the equation has to be equal to 0 to solve, which was different from what we just did with square root property, right? Okay. The quadratic formula is x equals negative b plus or minus the square root of, it's a big square root, b squared minus 4 times a times c, and then you take all of that and put it over 2 times a. There is a song, but you are not 10th graders, and I'm not going to sing it to you. You can look one up on YouTube if you want a catchy tune to help you remember the formula. But there are plenty of them out there, okay? It's not a hard formula to remember if you just listen to the song, basically. That's how I remember. Well, that's not how I remembered it, but that's how a lot of my students remember it. We're going to start with this example. 2m squared plus 3m minus 7 equals 0. We've been asked to solve for m. Okay? We're going to use the quadratic formula. It's possible that this will factor. I haven't looked at it to see if it will or not. But see, this would be one that I would go, I can't see how that one would factor easily. I'm going to use a quadratic formula. That would be my thought processes. Okay? I like to write what my a, my b, and my c are because that's what I'm going to be substituting into this. A is 2, b is 3, and c is negative 7. So you're going to put it, so instead of it saying x equals, this one's going to say what? M equals, right? Because m is my variable that I'm solving for. Is that correct? Okay, m equals negative b, so negative 3, plus or minus square root of b squared, so 3 squared. Now, you can put parentheses around the 3, but if it's not negative, you don't have to. If the b is negative, you need to put parentheses around it. Okay? Anytime you're putting a negative number in this, or the c, or the a, if any of them are negative, you need to put parentheses around them. So b squared minus 4 times a, which is 2, times c, which is negative 7. And I'm using parentheses there to show multiplication, all over 2 times a. All right? You must use your order of operations. We're going to go underneath this radical, and what would we do first? Well, I can tell you can do two things kind of simultaneously. You're going to square the 3. Exponents are definitely high up on the priority list there of order of operations. And you can multiply these 3 numbers in the same line if you want to, because that would be your next step. When you multiply the 4 has what sign in front of it? A minus sign. Think of it as a negative. Okay, so negative 4 times 2 is negative 8, and negative 8 times negative 7 is positive 56. And you write plus 56, because that is b squared minus 4 times a times c. So you're going to have a plus or a minus in between those two numbers. And then you can go ahead and do 2 times 2, which is 4. Okay, y'all make sure that I don't mess up, because I don't have this one worked in my book. So I need you checking me on my math as we're going through it, okay? Making sure that I don't make any mistakes. It's late. What is 9 plus 56? 65 all over 4. Now, are there any perfect square factors in 65? 4, 9, 16, 25, no. I don't think there are any. So there's no way for me to simplify this. So my answer is, I have 2 answers here, don't I? I have negative 3 plus the square root of 65 over 4, and negative 3 minus the square root of 65 over 4. So if I were to graph this, and this were my x, if this were x instead of m, and I were to be graphing this is where it would cross the x-axis. You would need to see a decimal approximation to know what that was about. But we're going to leave our answers like this. I can't think of any way to break that down any further. Any questions? All right, let's do another one just so we're really familiar with it. So we're going to solve x squared minus 6x plus 4 equals 0. What is a? We're going to solve it by using the quadratic formula. What's a? A is the number on the x squared term. What is it? What is a? 1. What is b? Negative 6. Notice you take the sign that's with it. And what is c? 4. So we're going to plug it into the quadratic formula. It's x equals negative, b is negative 6, so I'm going to use parentheses right there so I don't mess the signs up. Plus or minus the square root of b squared. Again, using parentheses to show that I'm squaring all of b, the negative and the 6. Minus 4 times a times c all over 2 times a. That's positive 6. Negative negative 6 is positive 6. Plus or minus the square root of negative 6 squared is positive 36. And negative 4 times 1 times 4 is minus 16. all over 2. I'm going to continue over here with my work. X equals 6 plus or minus. The next step would be subtraction. The square root of 20 all over 2. Then you're going to need to break 20 down. What does 20 break down into? 4 and 5. I like to just write it here. So you get x equals positive 6 plus or minus 2 square roots of 5 all over 2. And then here's where we have to remember, we talked about it I think about a week ago. If all of these outside numbers are divisible by the same factor, then you would divide them by that. It's called reducing the fraction. Okay, you just have to recognize it. So x equals 2 goes into all those, doesn't it? Right? So 2 goes into 6 3 times, plus or minus. 2 goes into the 2 1 time. I don't put a 1 in front of a radical. And then 2 goes into 2 1 time. It might be nice if you do this. 2 goes into 2 once, it goes into 2 once, it goes into this 3, and then you write your answer. 3 plus or minus square root of 5. Okay? Sometimes, do you have a question on that one? I'm sorry. Any questions on that one? Sometimes they're going to give you one that needs to be cleaned up before you can solve it. So perhaps a problem that looks like this. Now that one is a mess, but you've been asked to solve for x. And we're in the quadratic formula section, so I want you to solve it by using the quadratic formula. The first thing you're going to have to do is get it to look like ax squared plus bx plus c equals 0. So you're heading towards that. Okay? So we're going to distribute the 3x. I will get 3x squared minus 18x equals x minus 20. And then I need to move everything to the left side with my x squared term so that it will be equal to 0. So I would need to subtract this x. And what do I need to do with the 20? It's minus. What would I need to do with it? Add it, right? To get 0 on the right side, because that's what we needed. So you have 3x squared. Negative 18x and negative 1x makes negative 19x plus 20 equals 0. Now I'm not going to go through solving this one. It's going to be the same thing. A is 3, B is negative 19, and C is 20. These numbers are kind of big, so they're not going to be real fun to work with. But you see what you have to do to get it where you can use the quadratic formula. You must get it in the form ax squared plus bx plus c equals 0. Now, so you can finish this on your own if you want to. Now what I want to talk about is a part of the quadratic formula. This piece of the quadratic formula, the part that's underneath the radical, b squared minus 4ac, is very special. Okay? It is called, it has a name. It's so special it has a name. All right? So b squared minus 4ac is called the discriminant. The discriminant can tell you how many solutions and what kinds of solutions you are going to have. Just that part of it. Because it's underneath the radical. If it's a perfect square number, then you can take the square root of it. If it's a positive number but not a perfect square, then there's going to be another situation. If it's a negative number, you're going to have imaginary solutions. Okay? That part, this part right here that goes underneath the radical, is very important in being able to tell you what kind of solutions you're going to have. If b squared minus 4ac is greater than 0, there will be two real solutions. And I'm going to abbreviate solutions SOLNS. You are welcome to write the whole thing out. So this is your first rule, your first case of it. Part A of that is if b squared minus 4ac is a perfect square, the solutions will be rational. Part B is if b squared minus 4ac is not a perfect square. Yeah, that's right. The two solutions will be irrational. Now remember, a rational number is a number that can be written as a fraction. An irrational number is a non-repeating, non-terminating decimal. The second case is if b squared minus 4ac is less than 0. So if the discriminant, which is the value that's underneath the square root, is less than 0, that means it's a negative number, then there will be two imaginary solutions. And the last case is if it's equal to 0. So if b squared minus 4ac is equal to 0, there will be one rational solution. So on these next few problems, all I'm going to ask you to do is to tell me how many and what type of solutions I will have, not what are they. Okay? So how many and what type of solutions do I have for this equation? many and what type. If I only ask you how many and what type of solutions, that means all you have to do is compute b squared minus 4ac and see which one of these cases it fits into, okay? If I ask you how many and what type, and then I ask you to solve it, then you would have to go ahead and do the quadratic formula as well like we did previously. But I just want to know how many and what type. So I'm going to find b squared minus 4ac. b is negative 5, is that correct? Make sure you put it in parentheses before you square it. Minus 4 times a is 2 times c is negative 12. So that's positive 25. And then negative 4 times 2 is negative 8. And negative 8 times negative 12 is positive 96? I don't know. I can't remember. Yes, that's right. Then you're going to add 25 to that, and you're going to get 121. So your discriminant is 121. So which one of these cases does that fit into? Is b squared minus 4ac greater than 0? Well, is 121 greater than 0? Yes. Okay, then I know there are two real solutions. Now I have to decide, is it A or is it B? If b squared minus 4ac is a perfect square, the two solutions will be rational. If it's not a perfect square, they will be irrational. Is 121 a perfect square? What's the square root of 121? 11. It is a perfect square. So there are two real, rational solutions. That means that there will be either fractions like 1/2 or 3/4, or whole numbers or integers like negative 2, positive 4, or something like that. Okay? This particular answers are in your book. There are 4 and negative 3/2. Those are rational real numbers, 4 and negative 3/2. All right, let's do one more of those. Same question. I don't really want you to find the answer on this. These are actually done for you in your workbook where they actually go ahead and find the answer, so you're welcome to look at them. I just want us to focus on the discriminant and what it means at this point. So if my equation said 1/2 x squared minus 2x plus 3 equals 0. I want to find the discriminant. So the discriminant is b squared minus 4ac. So that would be negative 2 squared minus 4 times 1/2 times 3. Negative 2 squared is positive 4. And then 4 times 1/2 is 2, and 2 times 3 is 6. So it would be minus 6. 4 minus 6 is negative 2. So I'm on case 2, aren't I? If b squared minus 4ac is less than 0, there will be what kind of solutions? Is this less than 0? Negative 2 is less than 0, right? What kind of solutions are there? imaginary. There will be 2 imaginary solutions. This is solved for you using the quadratic formula in your book. On workbook page 442 is where there are some other examples of that. Okay? All right, so now we're going to talk about graphs of quadratic functions. Graphs of quadratic functions are, and this is actually the same section, it's kind of a switch in gears though. Graphs of quadratic functions are shaped like parabolas. They will either look like this or like this. They go on forever and ever, either up or down. Where they cross the x-axis is called their x-intercepts. So their x-intercepts are the solutions to the equation, which I said that a minute ago. Some parabolas will not cross the x-axis. Those have no solution, or actually in our case they have imaginary solutions because we've defined imaginary solutions now. Okay? There are 3 pictured on page 443 in your workbook. So if you'll look at page 443 in your workbook with me, so we can just kind of talk about those pictures. This says video 7. It says determine the x-intercepts of the given function. Okay, so the first one intercepts the x-axis in 2 places. Do you see it? Those 2 places are, I can't see it. Can anybody tell where they're at? Looks like we can't actually see them. Do they look like they're maybe at fractions or decimals? Okay, so I can't see them. It's very tiny for my eyes, but what about, but they're real numbers though, aren't they? So that parabola has 2 real rational solutions, okay? What about the second one? Where does it intercept the x-axis? I think it does. It's right on a number. What number is it on? 2. That's the only place. So that one only has 1 solution, okay? And then the third one does not intercept the x-axis, so it has 2 imaginary solutions. So how many x-intercepts are possible for a quadratic graph to have? What was the maximum number of x-intercepts you could have? 2. So it could cross it 2 times. It could cross the x-axis 1 time by touching it. That little turning point where you saw it touching it is called the vertex. So the vertex could actually sit on the x-axis, or it could not cross it at all. Those are the same 3 scenarios that we have right here when we're talking about our discriminant. For this one, it will cross it in 2 points. For this one, it will not cross it at all. And for this one, it will touch at the vertex on the x-axis. Okay? So those are the same scenarios here. We're just talking about them now in graphical form. Now, to find the x-intercept of a graph, without solving the equation, to find the x-intercept, you will set the y variable equal to 0. To find the y-intercept, and I love this, I get to tell you a little secret. To find the y-intercept, you would set the x equal to 0, but really, we don't have to. If the equation is written in ax squared plus bx plus c form, if it's in that form, the y-intercept is always the c. Now that should make sense to you, because if you put 0 in here and here, those would go away, and the c would be all that would be left. So it's going to cross the y-axis at the c, and to find the x-intercept, you'll have to put 0 in for y. Now that's what we've been doing. Hasn't 0 been here every time we've been solving all of these? We've gotten them equal to 0. So now what we're going to do is we're going to see this equation with a y here or an f of x, one or the other. Those are the same thing. And we're going to be asked, where does it cross the x-axis? Well, you're going to put 0 there to find out. Where does it cross the y-axis? Okay? So let's look at example, well, I don't know what example it's called. It's called video 8. Video 8. It's already graphed there for you, so we don't have to graph it. We just have to find the x-intercepts and the y-intercepts. So f of x is the same thing as what? The y. So if this makes you more comfortable for this particular situation, because they have asked us to find the x-intercept and the y-intercept, then by all means, put it there. Okay? To find the x-intercept, we have to set y equal to 0. So I'm going to put 0 in for y. 1/2 x squared minus 2x plus 3. Is this one that I did earlier? It's not, is it? I don't think so. It is? Where did I do it at? It's similar. Oh, it is. Okay, so I found the discriminant a minute ago for it, but I'll just go ahead because I didn't solve it. Okay, so we're going to solve this with the quadratic formula. So x equals negative b, which is negative 2, plus or minus square root b squared, negative 2 squared, minus 4 times a, which is 1/2, times c, which is 3, all over 2 times a. Remember, the x-intercepts are your solutions when y is 0. So it's going to be positive 2 plus or minus the square root of, and I did this a minute ago. It's 4 minus 6, so it's negative 2. Oops, I forgot to put the a in. 2 times 1/2, sorry. My bad. And 2 times 1/2 is what? 1, right? So I'm going to move over here. I'm working sideways because I'm running out of room. I want to keep these directions available for us. So I'm going to get x equals 2 plus or minus I root 2. Those are what types of solutions? We said right up here that those would be two imaginary solutions. Are those two imaginary solutions? Yes. Okay. So does this have any x-intercepts? No, because it's imaginary. It doesn't cross the x-axis anywhere. See the picture. X-intercepts are where it crosses the x-axis. Look at the picture in your book. Does that graph cross the x-axis anywhere? No, it doesn't. So it has no x-intercepts because they are imaginary. Now let's talk about the y-intercept. I gave you the little secret. What's the y-intercept of this? What did I say it would always be? What's the c? 3. So the y-intercept is at 3. If you wrote it as an ordered pair, it would be 0, 3. Look at your graph. Does it cross the y-axis at 0, 3? It does, doesn't it? Okay, so that's how you would perform this particular problem where it's asking you to find the x-intercept and the y-intercept. Any questions? Okay, we're going to pause again.